Okay, so this question asks us to find the equation of the tangent to the curve y equals x cubed minus 9x squared plus 20x minus 8 at the point 1, 4. So ignore all the dots in this linear line for a second. The green line is the line y equals x cubed minus 9x squared plus 20x minus 8. What the question is asking us to do is find the equation of the tangent to the curve at the point x equals 1, 4. That point is right about there. It wants us to find how steep that line is there. Okay, so what we need to do is to find the gradient of that point. What we can do is we can differentiate this, because when we differentiate this, the differentiated form tells us the gradient at any x point. And then what we're going to do is we're going to substitute in an x value of 1 in this case to see what the gradient of this tangent is. We know that the tangent is going to take the form y equals mx plus c, because a tangent is a linear line that just touches at that point, at a certain point on the graph, but it doesn't cross it. So once we work out this m value, the gradient, we can substitute in some values and we can find the c value. So let's try that. So the first thing we need to do is to find f dash of x, or dy dx if you prefer. The derivative is all I'm trying to say of this function. So the derivative will be 3x squared minus 18x plus 20, and that's it. Okay, the next thing we need to do is we need to substitute in an x value of 1, because we want to know the gradient at the point x equals 1. So let's do that. So it'll be f dash of 1 equals 3 times 1 squared minus 18 times 1 plus 20. Alright, bit of quick maths. It will be minus 18 plus 20 is 2, plus 3 is 5. Okay, so we know so far that the gradient is 5, x plus c. Does 5 seem like a reasonable gradient? Well, it seems like it to me, because the gradient here is positive because it's sloping upwards, and it seems reasonably steep. So 5 seems like a perfectly reasonable answer. So the next thing we need to do is we need to substitute in a point that we know is on this line. We know that this point here, 1, 4, is on the line of the tangent, and it's also on the curve. So what we can do is we can substitute in that point to find the c value. We know that when y is equal to 4 on that line, our x value is equal to 1 plus c. Okay, then what we do is we subtract 5 from both sides. We get 4 minus 5 is negative 1. So our whole equation, if we can write it in red, will be y equals 5x minus 1. And that's the equation of the tangent to the curve at the point 1, 4. The next thing we need to do is think about this question. At what points on the curve is the tangent parallel to the line 4x plus y minus 3 equals 0? Okay, the line that I've drawn, this black line here, is that linear line. So it's not written in our traditional form that we see it, so let's see if we can rearrange it so we can see what's going on a little bit. If I rearrange it to make y the subject, well, I'm going to get y equals, subtract 4x from both sides, and add 3 to both sides. And we can see now that we just have an equation in the form y equals mx plus c. So you can see as well on this black line here, which I've said is this line, I've claimed is this line, it has a y-intercept of 3 and it has a gradient of negative 4. So the question here says, at what points on the curve is the tangent parallel to the line 4x plus y minus 3? So what we're looking for is points, and I've given it away a little bit. These 2 points I've drawn on here are parallel to this black line, which is what the question is asking, and it wants us to find the coordinates of these points. So you can see, even though my drawings are pretty bad, that this line and this line are parallel, and this line and this line are parallel. And what we're trying to do is to find the point on the curve where the tangent is parallel to this line. So how are we going to do that? Well, we know from this question, from this part, that the gradient of that line is -4. We also know from the previous question that the gradient of the green function, of the original function, is given by this equation here, 3x squared minus 18x plus 20. So what we can do is we can say, all right, well, the gradients have to be equal. If the gradients are equal in any two lines, they'll never intersect because they have the same steepness. As soon as they have a different steepness, they're going to intersect at some point. So what we're going to do is we're going to say, all right, dy dx then must equal -4. So -4 equals 3 times x squared minus 18x plus 20. Okay, so that gives us, and then what we're going to have to do is to find the x value. We just have to solve for this x value. If I add 4 to both sides, I get 3x squared minus 18x plus 24. Okay, then from here, we need to use our quadratic solving skills. So we're going to say we're going to take 3 out as a factor to make our life a lot easier. So it's going to be x squared minus 6x plus 8. Okay, now all we have to do is factorize the inside bit and remember to carry the 3 in. So 0 is going to be equal to, well, what multiplies to give, I'll just do it over here in a different color. What multiplies to give AC, which is 1 times 8, which is 8, and B, which is -6. Well, that looks to me as though it's going to have something to do with 4 and 2. 4 and 2, but it's going to have to be -4 and -2, because -4 times -2 is +8, -4 plus -2 is -6. So that's going to give us 3 times x minus 4 times x minus 2. So that gives us, we don't really need these big square brackets here at all. They're not doing anything for us. Using the null factor law, divide both sides by 3, and then either x minus 4 equals 0 or x minus 2 equals 0. So x equals 4 and x equals 2. Good, so we know that when the x value is 4 and when the x value is 2, the gradients of the tangent, the gradient of the tangent at that point is equal to, has the same gradient as this line, which is what the question was asking. So all we need to do now is substitute in these values back into the original equation to find the y value at that point. So the original equation says x cubed minus 9x squared. So it's going to be 4. I'm going to substitute in 4 first. X cubed minus 9 times 4 squared plus 20x minus 8 plus 20 times 4 minus 8. What do we got? So 4 times 4 is 16 times 4 is 64. 4 squared is 16 times 9. Well, 16 times 10 is 160, and then we've got to subtract 16 because they're only timesing by 9, so what's that? 144 plus 80 minus 8. What do we have? 64 minus 144. That's going to be 60 minus 140 is -80. So 64 minus 144 must be -80. That's handy. Plus 8 minus 8. Okay, so that gives us a y value of -8. So one set of coordinates is 4, -8. And you'll see from up here, that will be this point down here, 4, -8. 4, -8. And take my word for it that the other point is, let's do it, might as well. Y equals, so it's 2 cubed minus 9 times 2 squared plus 20 times 2, minus 8. Hopefully I don't make a mistake, so that's 8 minus 9 times 4 is minus 36 plus 40 minus 8. Minus that goes with that. the y value, minus 36 plus 40 is 4. So y equals 4, so that gives us the point 2, my x value is 2, and my y value is 4. So scrolling back up here, we can see that this point here, if a pen would work, this point here is 2, 4. And what we've said is, at this point here, 2, 4, and this point 4, negative 8, the tangents at those points are parallel to the line 4x plus y minus 3 equals 0 because they have the same gradient, which we set up over here by saying that the gradient must be equal to negative 4. So, okay, so this question is asking us, well, it says the following: the curve with equation y equals x squared plus 3, show that y equals 2ax minus a squared plus 3 is the equation of the tangent at the point a squared plus 3. Alright, let's not freak out about the fact that there is a's and things in this. We just treat it with the same logic and hopefully understanding that we do with other questions to do with tangents. So all it's saying is that anywhere randomly with the value of an x value of a, it says that the equation of the tangent at that point is equal to this business right here. Alright, so with any question that asks us to find the equation of the tangent, we know the equation of any tangent is going to have the form y equals mx plus c. So there's a couple of things we need to know. We need to know the gradient, and we need to know the c value, or the y-intercept. The first thing that we're going to work out is the gradient. And by now, hopefully, we know that when we're talking about gradients, we're talking usually something to do with the derivative of the function. So what we're going to do to find the equation of the tangent, we're going to differentiate our original function to get the derivative function. So f dash x, or dy dx, in this case is equal to 2x, just 2x. So just to make that clear, this is y equals x squared plus 3, and the derivative function is just 2x. Okay, now the question is, show that the gradient is this. Show that the equation of the tangent is this business here. So what we're going to do is we're going to say, alright, we want to know the gradient at the point A. Well, how do we do that? Well, we simply just substitute in f dash of a, and that tells us the gradient at the point A, and that's just simply going to be 2a. So with our equation of our tangent, so far we know that it's equal to 2ax plus some c value that we're not quite sure on yet. Alright, what can we do from here? Well, to find this c value, we need to know a point on the graph. They've given us a point here. They've told us that at the point A, the y value is equal to a squared plus 3. So say, for example, this curve here, we've got it and we've got some tangent. They've told us that this coordinate here at the tangent point is equal to a squared plus 3. Okay, and then we know that this point is not only on the green line, on the original function, it's also on the tangent line, because that's the definition of a tangent. It touches it at just one point without crossing it. So what we can do is we can substitute in the y value and the x value and solve for our c value. So we know that when our y value is equal to a squared plus 3, our x value is equal to a. Okay, solving this, we get a squared plus 3 equals 2a squared plus c. And then subtract 2a squared from both sides, so we're left with c equals minus a squared plus 3. Hopefully I got that right. Subtract 2a squared. Yep. Now we know everything we need to know. So the equation of our tangent, even though it's in all these abstract terms of a's and things like that, is just going to be equal to 2a, because that was our gradient that we decided before from here, 2ax minus a squared plus 3. this is our C value that we just worked out. Good, and it was to show that question, so we put a big square and we say, as required, something like that, or QED, that's the other thing people say. All right, so the next question says, hence, find the coordinates of the 2 points on the curve, the tangents of which pass through the point 2, 6. The wording of this question is quite tricky to get our head around conceptually, but let's see if we can do it. So what it's asking for is 2 points on the curve where if I were to draw a tangent at that point, both of those tangents would pass through the point 2, 6. So for argument's sake, let's say there's a point here. Let's say there's a point there, and let's do it in a different color. Let's say there's a point there, and there's a point here. Just use this line because we've already drawn it. And that is terrible. Extend it like that. Okay, and another tangent here. Now both of those, this question is asking, need to intersect at the point 2, 6. Obviously these two aren't intersecting at the point 2, 6, but the question is to find 2 points on the curve where both of those lines pass through the point 2, 6. Now the question is, how are we going to do that? Well, what we're going to do is we're going to say that the equation of the tangent here, we know that at any point A, this is the equation of our tangent. Okay, so what we can say is the equation of our tangent, which is this, has to pass through the point 2, 6. So what we can do is we can find A values such that our equation of our tangent, or our tangent, passes through the point 2, 6. And what that looks like when we put it in mathematical terms is we're going to say our y value is 6 when our x value is 2 minus a squared plus 3. And the reason we're doing that is because we know that this equation here is the equation of our tangent. And we have said in the question that the equation of our tangent needs to pass through the point 2, 6. So we can substitute those values in, and what you'll notice is we can get different a values out. So let's have a look. If we can solve for this, we get 6 equals 4a minus a squared plus 3. Subtract 6 from both sides. We get 0, that's gone away. 0 equals 4a minus a squared plus 3 minus 6 is minus 3. Okay, now, just because I like it in the usual form. Alright, now you'll notice we have a quadratic in A, so we're going to solve that. And whenever I do this, I like to make sure there's the coefficient of the squared term is 1, a squared. If we've taken negative out there, that's minus 4a plus 3. Moving up here just to solve it real quickly. Alright, well, it multiplies to give 3 and adds to give negative 4. Well, let's do it over here. AC equals 3, B equals negative 4. That's going to be 3 and 1, but it's negative 3 times negative 1 is positive 3, and negative 3 plus minus 1 is negative 4. So we're going to say it's going to be A, so we don't need those brackets, it's going to be A minus 3, A minus 1 equals 0. And then we're going to say, all right, therefore using the null factor law, A equals 3 and A equals 1. Okay, so now what we have is our A values that give us the equation of a tangent that passes through the point 2, 6. So all we have to do is substitute these points into our equation of our tangent here, and that should tell us 2 tangents that pass through the point 2, 6. So let's have a look at what happens if we do that. Y equals 2 times 3 times x minus 3 squared plus 3. So that's subbing in a equals 3. So that gives us an equation for the tangent of 6x All right, minus 3 squared is minus 9 plus 3 is minus 6. So there's one answer. Let's see if we can work the next one out. The next one will be subbing in an a value of 1. So it's going to give us 2 times 1 times x minus 1 squared plus 3. Okay, that gives us 2x minus 1 plus 3 is plus 2. And that's our second one. So now what we have is two lines that we know are tangential to our original equation, x squared plus 3. Now the question is, where, at what points, aka in the question it says find the coordinates of the 2 points on the curve such that the tangents pass through the point 26. So we know that these are the equations of the tangents, but what are the points that they actually go through on the curve? The points that they touch on the original curve, I should say. So let's see if we can do that. So if we want to find where the original curve and these tangents intersect, we just have to let them equal to each other, set them equal to each other. So we say the original equation is x squared plus 3, and we have to set that equal to maybe 6x minus 6 first. All right, see if we can solve this. That gives us add 6 to both sides, so it's x squared and minus 6x from both sides plus 9 equals 0. Multiplies to give 9, adds to give minus 6 is minus 3, so it's x minus 3, x plus 3 equals 0. Both x minus 3, I should say, equals 0. Okay, and so that gives us an answer of x equals 3. So what we have here is a situation where, I'll write it like this, we've got x minus 3 squared equals 0. Alright, solving this gives us x equals 3. But if you think back to cubics, and remember when we had an intercept that just touches the x-axis, and we said that would be something of the form like x minus a squared at this point here, because when it just touches it, just like a tangent does, it has this form of x minus a squared. So in this case here, we know that one point is x equals 3, and the other point we can do here is we've got to say x squared plus 3 is equal to 2x plus 2. Okay, x squared minus 2x plus 1. Okay, multiplies to give 1, adds to give negative 2. That's going to be x minus 1 squared. Okay, again, so in the same logic as before, we can say x equals 1. Alright, now that we know x equals 1 and x equals 3 are points where our equation of our tangent touches our original graph, we can do the following. We can just substitute them in to into either equation to find the y value. So in this case, I'm going to do it into the original equation. So I'm going to find my y value when my x value is 3 for the original equation. So we're going to say 3 squared plus 3. So my y value is equal to 9 plus 3 is 12. So that gives us coordinates of 3, 12. And the next one here, just to show that I can substitute it into either one, is going to be y is equal to 2 times 1 plus 2. Okay, y is equal to 4. So another set of equations is the point 1, 4. Okay, that got pretty abstract, so let's think about what that looks like in the graph. Alright, so here we have the original curve in green, and what we've said is that there is two tangents at certain points that if you were to draw the tangent at those points, they would intersect at the point 2,6, or they pass through the point 2,6, which is here. So, and what we've shown is that if we draw a tangent at the point 1,4, we get this black line here, and that passes through the point 2,6. And if we draw a tangent on the green line at 3,12, we get this purple line here. And all of the business we did before was to show and to find these coordinates. We know if we draw a tangent at 3,12 and at 1,4 on the original curve, they intersect at the point 2,6, and they both pass through that point. So hopefully the graphical representation makes it a little bit clearer what we were doing. Quite a tricky question. It's tricky to know what you have to sub into, and but yeah, hopefully the process of stepping it out helps you a little bit with that.